Great to see you here. I hope you've been at our channel before. If it's the first time you visit the YouTube channel of the Koster Academy, do not forget to click the subscribe button. If you've been here before and you didn't subscribe yet, it's the moment to do it before we start with the video. Click on the bell button and you will be informed every time we have a new video. We have another exercise here about the application of Fermat's little theorem, and in this case we're having a little bit more complex example, because we will see that after the application of the theorem, Fermat's little theorem, the number we find is still rather large and we have to apply the modular exponentiation. Nevertheless, the operations will be a lot faster and a lot easier. So anyway, we make some better time to finish this exercise. Now what do we have here? First of all, P is equal to 17. So 17 is prime, so that's okay. We can use Fermat's little theorem. We have A is equal to 15, and we can say that A to the power P minus 1 is congruent with 1 modulus P. So when we're going to do that here, we can start basically that 15 to the power 16 is congruent with 1 modulus 17. We have 15 to the power 32, we always take the square, is 1 modulus 17. 15 to the power 64 is congruent 1 modulus 17. And 15 to the power 28 is congruent with 1 modulus 17, and we can continue. Now we've seen before that it's easier to use a shortcut, and we can say that 1273 is equal to basically 79 times 16 plus 9. And here we know that 15 to the power 79 to the power 16 is congruent with 1 modulus 17. So basically we can take that out of the equation and we only consider the 9. So now we can calculate 15 to the power 9 modulus 17. Now we see 15 to the power 9, it's still quite a large number. Our calculations may be, let's say, showing a problem. If you have a simple calculator, if you have more capacity, it may be that it's perfectly doable. On the other hand, let's see if we have another way to resolve this. And when we look at the fast exponentiation algorithm, remember that we found a way to do this a lot faster. Let's have a look how we can solve this equation using the fast modulation or the fast exponentiation algorithm. Before we've proven that 15 to the power 1273 modulus 17 is equal to 15 to the power 9 modulus 17. Now what we have to do here, when we look at the fast exponentiation algorithm, we have to say that m equals 15, and on the other hand e in decimal notation is in fact 9, and e in binary notation is 1001, so we have to have the index here. Now when we are going to look at this, we have to use the binary expression of e. So we have 1, 0, 0, 1. We know that we have d to the square when 0, and d to the square and md when 1. So basically those are the conditions that we have to take into account when we're going to do the modular exponentiation, and we start from d0 is equal to 1. So basically we have here d0, I will take a different color to show this and put that a little bit farther away. So we have 1, 0, 0, 1, so we have d0 to the square is equal to 1. Modulus 17, it's still 1, we don't have to do anything, but now we have to multiply with n, so we have 15, and 15 modulus 17 is in fact still 15, so we find d1 after the first iteration is 15. Now we go to the next step, we have 0, so we only have d to the square. 15 to the square is 225. 225 modulus 17. Well, here we find that d2, we call it d2, is equal to 4. We continue now again, we have 0, so we only have to have d2 to the square, so 4 to the square is 16. 16 modulus 17 is still 16, so d3 is equal to 16. We go to the last one, we have 1, so we first have to take the square of d3. So 116 to the square is 169. So basically, 196. 196. And 196 modulus 17, when we calculate it, this is equal to 1. And then we have to multiply times m, so times 15 is in fact d4 is 15 modulus 17, which is still 15. So basically at the end we can say that this is equal to 15. So basically what we did here is combining two ways of calculating those powers and finding the moduli. First we used the theorem from Fermat's little theorem, and then we used the modular exponentiation algorithm, the fast modular exponentiation algorithm. So that was it for this other exercise about Fermat's little theorem. Do not forget to have a look at the description below the video. You will find all those links to all our courses with great coupons that will give you a fantastic discount. Anyway, before leaving here, do not forget to click the subscribe button. Click on the bell button so every time we have a new video, you will be informed. Thank you very much and bye-bye.